Chapter 10, Chi-square. What is the chi-square? A chi-square is a statistical hypothesis test that uses bivariate tables to determine whether or not a relationship exists between variables. It is one of the most commonly used hypothesis tests in social science because the assumptions that need to be made in step 1 of the 5-step hypothesis test are very easy to satisfy. The reasons for this are the test can be used for any level of measurement, ordinal, nominal, interval ratio. The test is also non-parametric or distribution-free, and therefore requires no assumptions about the shape of the distribution. Before we give an example and go through the 5 steps of the hypothesis test with the chi-square, certain aspects of it must be explored. Although the chi-square can be used for any level of measurement, it is best used with nominal variables. The null hypothesis for a chi-square states that there is no relationship between the variables and that they are independent of each other. Further, any statistical relationship occurs by pure chance. Now let's jaunter through the 5-step hypothesis test using a chi-square. Step 1. Making assumptions and meeting test requirements. As previously mentioned, no assumptions are made in regards to the shape of the distribution. The model consists of multiple independent random samples, and the level of measurement can be ordinal, interval ratio, or nominal. Step 2. Stating the null hypothesis. The null hypothesis states that the two variables being tested are completely independent. If the null is true, the differences between the observed and expected frequencies will be small. As with all other statistical hypothesis tests, the null directly contradicts the research hypothesis. Step 3. Selecting the sampling distribution and establishing the critical region. Establishing the critical region for a chi-square is similar to establishing a Z or T critical. It requires 2 steps. You must first establish your alpha level, which is generally considered 0.05. Second, you must establish the degrees of freedom with the bivariate table using the formula C-1 times R-1, which would equal the degrees of freedom. The alpha level converted to a confidence interval and degree of freedom gives you the critical region by using Appendix C. For example, if the confidence interval is 0.95 and the degree of freedom is 4, then the chi-square critical will be 0.711.
Step 4. Computing the test statistic. Now that a critical region has been determined, the real fun begins. In order to find x squared obtained, the following formula must be implemented using the values from the bivariate table. So the formula is the sum of the observed frequencies minus the expected frequencies squared over the expected frequencies again. Now let's look at an example. In order to find x squared obtained, you will need to acquire the expected frequency for each cell. The formula for this is the marginal row times the marginal column over n. So for an example, for a social worker that is accredited, to find the expected frequency, we would take 40 times 55 over 100. Step 5. Making a decision and interpreting the results of the test. Now that we have both x squared obtained and x squared critical values, we can compare the test statistic with the critical region. If x squared obtained is greater than the x squared critical, then we reject the null hypothesis. However, if this is not the case, then we cannot confidently reject the null hypothesis as implausible. The limitations of the chi-square. While the chi-square is flexible enough to accommodate many different types of variables, it becomes difficult to interpret when the variables have many different categories. As a rule of thumb, the chi-square is easiest to interpret when both variables have 4 or fewer scores. The probability of rejecting the null hypothesis increases as the number of cases increases. Larger samples may lead to a decision to reject the null hypothesis when the actual relationship is trivial. Generally speaking, the chi-square distribution breaks down if expected frequencies are too low. It is still acceptable provided that there are no more than 20% of the events have expected frequencies below 5. Video demonstration. So this video will show how to use SPSS and calculate the chi-square statistic.
Good morning everybody, and welcome to this week's episode of Things You Learn in Stats class. This week's episode is all about the chi-square. So we're in SPSS right here, and we're going to try to figure out if we can find a relationship between these two variables, gender and political orientation. So what we're going to do is jump into variable view, and you're going to describe these with labels. So we have gender is obviously described as gender and political orientation here. So if you go to the values, you're going to want to denote men as 1 and female as 2. You're going to do the same with political orientation, where 1 is conservative, 2 is liberal, and 3 is NDP. Now before you continue here, make sure that your measurements as well are nominal. So you're going to go into data view here, and you see that we have a list of men and women who have varying different political orientations. So the question then remains, is there a relationship between these two variables? The easiest way to figure this out is by going to Analyze, Descriptive Statistics, and go to Crosstabs. Here you're going to put gender into rows, and political orientation into column. Before you continue here, go to Statistics, and make sure you check the chi-square box. You can also choose to click the Display Clustered Bars chart, as this will give us an even better representation of the relationship between these two variables. Okay, what we have here are three different tables. Now, the first one here describes the exact population, so we have 25 people who were surveyed, and all 100% of them were valid. The second table kind of distinguishes men and women and their political orientation. And what we can clearly see here is that there does seem to be a difference. We can't tell for sure without looking at the chi-square significance though, and that is in the next table right here. What we see is that the significance of the chi-square is 0.16, which is significantly less than 0.05. What this means is that we can reject the null, which says that there is no relationship, because statistically it shows that there is. And we can see this even more so when we look at the bar chart. The bar chart here shows us that there are a larger amount of women who are voting Liberal as compared to men. And so the bar chart is just an additive to get a more visual effect as the understanding of how effective the chi-square can be.